Hello, everyone. Welcome to the Computer Science Education Week webinar with BSD Education. If you're here with us live on Zoom, thank you for joining us. And those of you that are live on YouTube, thank you for joining us. And we'll see you in the comment section on YouTube or in the chat here on Zoom. And those of you that can't make it live and will be watching the recorded version of this later, thank you all. So welcome, and I'm going to go ahead and kick off the webinar since I have got a lot of material to cover today. This is the Computer Science Education Week, in which we have released some new content for our customers, as well as some free content. And if you've already started to look at content that's available on Hour of Code and you've seen our projects, I'll share some of our new projects today and make sure that you all have links so that you can access those now and in the future. But let me go ahead and share my screen, and we'll get started with today's webinar. So hi, everyone. My name is Mark, and the topic today is about uncovering bias with machine learning, kind of in the sense that we should be learning about this topic to build good digital citizens. And since AI and machine learning have become something that's very prevalent in the tools and technologies that we use, we need to make sure that students understand how those things work and how to keep themselves safe, and how those things might cause bias to come up, how to understand that bias, and then eventually how to affect that bias. So those of you that have been in my webinars before, those of you that haven't met me before, my name is Mark. I'm the Vice President of Education for BSD, and I oversee the curriculum development that we do at BSD, and also make sure that our curriculum follows along the pedagogy that we have laid out, which I'll share more information about, what is our specific pedagogy and why do we teach what we teach in a link later. But I also provide webinars in professional development, and currently also a student at Chiang Mai University here in Thailand, which is where I'm coming to you live from. And in my PhD, I'm studying the very topic that we will be going over today. It's about machine learning and how children perceive machine learning and artificial intelligence, and also how students can start to use it and understand how it works. So at BSD Education, we are a technology education company, and we provide three main things. We provide curriculum for schools. We provide a platform which students can log into and access the curriculum. And then we provide training and support to teachers so they can best deliver that curriculum. At BSD, we teach digital skills. So that could be content creation, database understanding, digital citizenship, but we also, on top of that, add coding to our projects. So we're teaching HTML, CSS, and JavaScript to students so they can design and make real web applications, video games, virtual reality experiences, artificial intelligence projects, kind of all wrapped into this nice platform that we've developed. So at BSD, we really work with educators, and our goal is to empower educators so that they have the ability to use these skills and teach these skills in the classroom with our platform. So we kind of have these three core areas in which we design our curriculum. The first is the actual hard skills that we're trying to teach, like coding, but also about data analysis, content creation. And because of the nature of the projects that we design, it requires students and teachers to communicate together, to collaborate, and there are opportunities for critical thinking. On top of that, we also have weaved in together through our curriculum the BSD values that we call CARE, which stands for curiosity, adaptability, resilience, and empathy. And there's a recorded webinar from a few weeks back about how we are able to take that CARE framework and weave it into all of our curriculum if you want to learn more about how those things all come together. Our curriculum development process has actually been certified by an organization in the US called Digital Promise. And Digital Promise looks at an education company's research-based methods, and they approve it and certify it as being, solidly understood and grounded in research. So I'm going to ask my colleague Beth, who's here on the call with me, to share out a link onto the chat. This link is going to provide you with all of the information that we need for today's webinar. So I'm going to be sharing quite a few things today. I'm going to be sharing some examples of our curriculum, some projects that you can do on your own, and also a link to this document that shows our certified curriculum development process. And it goes into more detail about our pedagogical foundation and how it aligns to what we develop. Those of you that are watching on YouTube, we'll make sure to put the link to this in the comments section. And anyone who signed up for this webinar will receive an email with the following information. So let's jump right into today's topic. It's about artificial intelligence. And the question I like to ask people who are experiencing artificial intelligence for the first time, or at least thinking about it, is, does AI affect anything in your life each day? And that really kind of depends on the technologies that you use and the things that you are involved with and things that you might already be using. But the answer is probably yes. It matters to the degree of which the things you're using. So here are some examples of things that you might be using that are designed with artificial intelligence. The first is digital assistants. So maybe you use on your mobile device, maybe you use Siri, or you use Alexa or some other digital assistant to remind you when your next meeting is, or you might ask it to save an item for you to go to the shopping to your shopping list later. So digital assistants are starting to become very popular, and people use them all the time. Not all of us have autonomous vehicles, but maybe you've been in an autonomous vehicle. So more and more vehicles these days have artificial intelligence technologies built in, and some are minimum, where they might just use artificial intelligence to help your car stay in the lane or help it back up into a parking place. And then there's fully autonomous vehicles in which you can kind of let go of the steering wheel and it does the driving for you. The next one is, this one maybe is not so much affected in our daily lives that we would see, but if you've ever ordered a package and had it shipped from a warehouse, like from Amazon or from Lazada or Shopee, one of these really big major networks that does shipping and receiving, they probably use robotics, to get that package to you in some way, shape, or form, whether it's moving the package across the floor of a warehouse into a shipping container or into an airplane. Or in the field of robotics, there's also sensors that can monitor the flow of packages, and it scans the barcode, this kind of things. So, artificial intelligence is used to identify these things and then tell the robots what to do. Those of you that play video games have more than likely encountered artificial intelligence, because artificial intelligence has actually been being used in video games for a very long time. So, for example, if you're playing maybe like a Mortal Kombat style of game, there's always like the player, that you can control with your controller, and then there's the computer player. Well, the computer player is a kind of a very low level of artificial intelligence, but there are even artificial intelligence applications that can play chess and have been able to beat human chess players for several years now. Artificial intelligence is also being used to create and generate music and art. So, there have been full albums and songs that have even reached the top Billboard that have been created using artificial intelligence, at least for the music. Now, the artist might sing over the music that was created by AI. So it's kind of cool to see artificial intelligence being used together with humans to generate and make new types of artwork. And the cool thing about art, is it kind of starts a philosophical discussion about what really is art, what really is music, if it can be created by machines and robots and artificial intelligence, and we take away the human element to it, is it even still art? But that's kind of a whole nother can of worms you can get into with your students to ask that question. But this is the one that you're most likely to encounter on a daily basis, especially if you're on the internet using, Twitter, Instagram, Facebook, YouTube. Most popular social media applications use artificial intelligence to give you a suggestion about what you want to watch next or what you should look at next. Or if you're shopping online, if you're using Amazon, or if you're ordering books, usually there's some kind of an AI predictive system that will give you a list of suggestions about what you should watch or what you should do next or what you should buy. So I think this is the one that's kind of the most prevalent. And this one also kind of receives a lot of scrutiny, because sometimes you may get a recommendation or a suggestion that isn't appropriate, or that isn't anywhere near what you would typically watch, use, or purchase. So we'll talk a little bit today about how that starts to happen, and uncover some ways that we can affect that, change it. And I'm going to share with you some practical tools that you can use in the classroom, so that you can practice this with students. So today, the main objective of the webinar is I'm going to share with you this framework that we've developed at BSD and also with my PhD research about how to approach artificial intelligence with students and machine learning. But we're only going to look at a narrow field of machine learning called image recognition. So image recognition is just looking at images, still images or live images. So we could look at webcam images, video images, or still graphic images. So how does artificial intelligence identify those things, and how does it know what it is and then predict what it could be in the future? So those of you that haven't learned too much about the terminology of artificial intelligence and machine learning, what's the difference? So artificial intelligence is an umbrella. So it's a big category. And there are lots of different types of artificial intelligence softwares, algorithms, and systems. So machine learning is just one aspect of artificial intelligence. And so machine learning is really just the science in the field of computer science of getting computers to learn automatically by themselves without being explicitly programmed. So it's actually a really cool area of computer science, because we actually do get to use this program and have the artificial intelligence learn, which is a very powerful thing for a computer to do, because in the past, we've only been able to tell computers exactly what to do. Now, the one thing about machine learning that we all need to understand up front is that the machine learning is only as powerful, and it only knows as much as we're able to teach it. So while it can learn, it's not like learning on its own, like some super intelligent being where it's like searching the internet and reading books on its leisure time. It can only do what we've taught it to do, and it can only learn the things that we tell it to learn. So it has limitations. So what I'm going to be doing is I'm going to be sharing with you some activities that you can try in your classroom, and you can use these whenever you want, and you pick and choose which ones you want to use. But the reason why I'm presenting them in the order that I am is because we're building a scaffolded model of maybe a student has never encountered artificial intelligence or machine learning. This is the low stakes way to kind of build them up to a bigger understanding. So my colleague Beth shared out a link to that document. And in the document, there is a table of activities with links on there. So the very first activity is, if you click on that link, it's going to open up the webcam, and it's going to start to identify whatever it sees. Now, I'm not going to show that right now, because most web browsers don't allow you to show your webcam into more than one type of software on your computer. So I'm currently using my webcam on Zoom. And so if I were to show my webcam on Chrome or Firefox, then it would crash my Zoom webcam. So I'm not going to do that. But so if you click on this link, it's going to open up the webcam. And then at the bottom of the screen, it's going to start to show you what it thinks it sees. And so this machine learning tool it can't recognize everything in the world. That's just, there's no machine learning tool that can recognize everything in the world. So this machine learning tool has been trained to recognize a lot of common everyday objects. So it can identify a backpack. It can identify a mug, a water bottle. It can identify a guitar, a ball, just kind of like common everyday things you might have laying around your house. It's also really good at recognizing different types of animals. So if you got a dog, a cat, a mouse, a snake, something like that, you can show the webcam whatever animal you have. The other thing it's going to show you is the percentage of confidence that it thinks it is that thing. So if you hold up your backpack and it says, with a confidence of, 50 or 60%, then that's pretty high. So the machine learning tool is pretty confident that what it sees is a backpack. So with this activity, some things you can do is try multiple objects, try to see, what it can and what it can't recognize. And then the goal is to try to get it to identify something with above a 50% confidence level. So, in my experience with this tool, big objects like backpacks and guitars and things tend to really get you an above 50% confidence level. But if you just hold up your phone or a pencil, you're not going to get a high confidence level. And as we go through this webinar, you'll start to uncover and understand maybe why that's happening. Why isn't it so accurate? But the reason why I show this to students for their very first experience with machine learning is because I want them to see that the machine learning isn't perfect. It's only able to recognize some things and it can't recognize all things. And this is a common misconception. And there was some other research done a couple of years ago where a researcher asked children to score artificial intelligences based on how intelligent they think it is compared to their own parents. And so students, they would score like Google Alexa, Alexa and like just a Google search as being more intelligent than their own parents. So children often think that machine learning and artificial intelligence is super intelligent, but really only as good as what we teach it to do. So this is why this activity can kind of shift that thinking so that they understand that, it can do some stuff, but it's not, all powerful, all knowing. So the question I ask students after they do this activity is, the webcam can see, but how does it recognize something? So when you and I look at something, we have labels in our mind, and our mind immediately starts to label something, especially if we've already seen something before. So it's like, if I see my mug here, I can classify that, label that as a mug. But how does a computer able to do that? How can a webcam see something and then identify what it is? So the way that computers understand information is actually not through images. Computers cannot see. That's a misnomer. Computers can only understand numbers. They can only understand data. So we have to be able to take the image and take the picture and turn it into data. So this is how the computer does that. So the computer can take a still image or even a motion image, a video, and it can break those down into pixels. So this is just an example. Here's a high resolution image of Abraham Lincoln from Wikipedia. And so the first thing it does is it will break this image down into little squares. Those little squares, we call those things pixels. Then each pixel can have a value based on the color saturation. So if the color saturation is fully black, the value would be 0. And if the color saturation is fully white, then we'd have a value of 255. Every shade of gray in between that would be a value between 0 and 255. Now, this is a little bit more complex if we add in color. So color uses R, G, and B. So there'd be 3 different values. Those values can all be turned into one value as well. It's just a little bit more of a complex process. So it's easier to understand with a black and white image. So what the computer sees, and this computer does not see Abraham Lincoln, the computer sees this matrix. So a matrix is kind of like a table of numbers. And this matrix is the pixel value for each pixel of this image. So if you were to only look at this image on the right-hand side of this matrix of values, could you tell that it was Abraham Lincoln? Probably not. But the computer can tell that, especially if we tell it that this is Abraham Lincoln, and then we show it another picture of Abraham Lincoln later, it can kind of analyze those 2 images to see if it's close or similar or how different is it from the original image. So this is the first thing we have to understand about image recognition with machine learning, is that computers cannot see images, it has to break the image down into numbers, which the computer can decipher, understand, and compute. So how does our brain do this? So in our brains, we have a biological neural network. And so these little blue things, they're called neurons. So in computer science, we call these things nodes, and they're all connected together by branches and links. And these biological neural networks, they start to become really efficient, especially if you see something over and over and over again. So your brain gets really good at seeing your everyday surroundings. And so your everyday surroundings can be acknowledged and understood very quickly. But if we put you in a new environment that you've never seen before, if we were to teleport you to some remote location you've never seen before, your brain would have to take some time to adjust, and it would have to take some time to look around and see what it sees. But eventually, over time, it would start to understand that and quickly make sense of what it sees around. So in order for machines to be able to do similar tasks, computer scientists have developed artificial neural networks that work in very similar ways. So we've got the nodes of the individual neurons that are connected together by branches and links. And so we have input data, we have learning that happens in the middle, and then we have output data. So let me break that down a little bit more and kind of give you an example of how that might work using the Abraham Lincoln image. So I told you earlier that the machine learning can only do kind of what we tell it to do. So let's say that we wanted to build a machine learning tool that was really good at recognizing images of Abraham Lincoln. So what we have to do is we have to give it some input. So we have to tell it, this is a really good image of Abraham Lincoln. So this is we would call this good. These other two images are not so good. They're okay. They've got some good parts about them and some bad parts about them. So if we were to classify these, this one might be a 100% good image. This one might be a 50% good image, and this one might be a 75% good image. So we pre-label this information before we give it to the machine learning network. So in the middle, we call these hidden layers because we don't actually see them working in the model or in the field of machine learning. This is kind of like these extrapolations of data happen in the background. But what's happening here is the same thing that we saw earlier. It's breaking down the images into pixels. It's breaking those pixels down into values and then turning those into a matrix that it can compare and contrast. So then the output, it's gonna tell us, of course, this one is 100% good. So we already know that that one is good. But look what it's done to these other two. So it's kind of combined the best resolution between these two images to give us what the machine learning tool thinks is the best output. So it's come up with kind of like a yellowish or kind of greenish Abraham Lincoln compared to the other inputs of this yellow and orange one. So it's not quite as good as the 100%. So it might label this one as 85%. So the machine learning tool took these images and it did the best that it could with it. And so this machine learning tool is only good at recognizing pictures of Abraham Lincoln. So if you imagine any kind of machine learning tool has to be taught this information. So we have to tell it, this is a good picture of Abraham Lincoln, this one's not so good, this one's a little bit better, etc. So it would be the same process if we wanted to learn what a bicycle is or what a dog is. Here are some good pictures of dogs, here are some not so good pictures of dogs. Take in all that information, and then they will see outputs of different qualities. So another thing that happens in these hidden layers here is that the machine learning tool also starts to break down those images and it starts to look for similarities and differences. So when we're looking at facial information, the first thing it'll do is it'll start to look at low-level features, which are edges, lines, and contours. Then it starts to look at, kind of at the next layer, what are the shapes, eyes, nose, ear, mustache, that kind of stuff. And then finally, putting it all together, what is the overall facial structure? And then that is used to give us the final output. So in the hidden layers, the machine learning is making estimations, and they're predicting how all of these images are alike or not alike, so it can give it a value between 0 and 100%. 100% means it's exactly like the thing that we taught it. 0 means it's nothing like the thing we taught it. But even if we train AI a lot, we give it a lot of training information and tell it, these are the right images, it isn't perfect. So if you look at the image on the right, there are some chihuahuas in there, and then there are some blueberry muffins. So there's a famous example where a machine learning tool wasn't able to recognize the difference between the chihuahuas and the muffins. So we can look at this picture and we can easily tell the difference. Although for me, I think this one in the middle is pretty close. Like if I just glance, if I just kind of like turn my head and look, it kind of looks similar to a chihuahua. But then if I stare at it, it's like a mutated chihuahua face. So the question is, why do you think it was difficult for the AI to differentiate these images? Well, it's because the similarities are striking, especially this one. These other ones not so much. Maybe that one, maybe this one, but this one for sure. It's very similar. If the AI, if all it's doing is looking for lines, edges, eyes, nose, ears, and facial structure, then to the AI, that's definitely a Chihuahua. So another thing that we need to understand is that AI isn't perfect. And we have to cross-check it often, and we have to look for mistakes, and then we have to think about how we can fix those mistakes. So it's important for students to understand that AI still isn't perfect, and we need to be careful how we use AI because it's not perfect. So with that knowledge, one question I may want to ask the students is, what are some problems that you can think of that might occur if AI predicts the wrong thing? So if it predicts the wrong person, or if it predicts the the wrong YouTube suggestion, for example, or the wrong item in your Amazon wish list, what are some things that could go wrong with that? So this is a question I pose to students, and then we kind of have a class discussion and talk more about that. All right, so these next activities are going to build up towards learning how machine learning starts to do the learning process. And I've got 3 different activities for you to try out. So in the link that we shared earlier, there's like a table. It's like activity 1, activity 2, 3, 4, and so on. So right now I'm talking about activities 2 through 4. And these activities are all about sorting information. And if you just look at these activities at surface level, they're super simple. Like, a preschool child could do these activities. And we designed these in a way, not for you to test your ability, but really as a thinking exercise. So I'm gonna actually jump over and show you what these look like. This is the first one. So this first activity, all it's asking you to do is to sort the objects based on color. So at the top, you got some cards, and the bottom, you place the red objects and the yellow objects. So you got, obviously anybody can sort the difference between apples and bananas. It doesn't take a genius to do that. But think about how many times in your life you have seen apples and bananas. Your brain has been trained your whole life to comprehend these. What are these things? Those are not yellow bananas. Yeah, so what do I do with those? Well, in this activity, we're ordering things by color only. So I guess I'll put those here in the red. And then, I've got also these strange things like these are not red apples. So I guess I'll put these in the yellow category. So the first thing I want you to think about is, if this was a machine learning tool, and the machine learning tool, its only job was to classify things based on color, but we've got apples and bananas here and apples and bananas here. So could that present a conflict? Would that be some kind of an issue? So is it wise to classify things just on one variable? So is color enough information for us to classify? On the next activity, I'm going to ask you to classify them by type. All right, so now we've got apples and bananas. So if I start to put bananas here, I put apples here, put bananas here, apples here, you get the idea, right? It's just continues on. It's a simple activity, but it's really a thinking exercise. All right, so I got the red, oh, I can't put the red bananas here because I'm classifying by type. So that means that the bananas have to go there and the apples have to go here. So now, all of the items have been categorized by type. We got all apples here and all bananas here. But now I got red and here, and I got yellow here. So is classifying things by type enough information for us to classify things? So that's kind of what I'm trying to get you to understand, is that when we're classifying things, we need to look at all of the different aspects and all of the types of information about the object. The last activity, it's not using apples or bananas, but I'm trying to expose maybe something that you haven't seen before. So we all know what apples and bananas look like, but these cards, we have a variety of Hindi letters and Chinese letters. So maybe some of you out there know Hindi, or you know these characters already, and that will put you at a disadvantage for this activity. But if you don't know Hindi letters and Chinese letters, then you're kind of like, whoa, I don't know what to do with these. So you experiment around, all right? And the way this works is if you drop it into the wrong box, it kind of puts it back. So I can drop that here, and I can say, okay, oh, that's Chinese. What about this next one? Are there some similarities and differences between these types of characters? I see maybe this one has a really rounded part to it. It's got more, maybe it has less symmetry to it. Let's see where it goes. Okay, so that's a Hindi letter. What are the differences and similarities between these letters, and how can I predict the next one? So if I look at this letter and look at this letter, what prediction can I make about this one? I think it looks a little bit more like this one and less like this one, because it doesn't have as many curves. It's got more horizontal and vertical lines. So I'm going to drop that here. Okay, so now I have two data sets that tell me what kind of letters look like Chinese characters, and only one for Hindi. So here's my next card. What do you guys think? Hindi, Chinese? Looking at it, if you've never seen these characters before, you kind of compare and contrast, and you look and see what those might look like. So when you go through this activity, you start to categorize these things, and you're starting to think about how does my brain categorize these things, and how do I know, even if I've never seen these types of letters before, where is my brain getting that information from? So really, we start to look for patterns. We start to extrapolate how things might be connected. I'll let you guys finish that activity on your own time. But the goal is just to try something that you haven't categorized before and see how that works. So then I do a debrief with the students, and I ask them, how did your brain know to sort apples and bananas? Well, we've been learning from childhood about apples and bananas, so that's easy. So this is why small children are given the little blocks and toys to play with that are about pattern recognition. So can you stack the cubes all together, and can you put the right shape inside the right shape and the right color with the right color? So from a very young age, we're taught to distinguish patterns, and we're taught to recognize and see things. And our brain is really, really good at doing that. And so as adults, we have a database in our mind. We've probably seen millions of examples of apples and bananas. So we can look at an apple and a banana immediately, and we can decipher what it is, categorize it, label it, and know that there are some red bananas, there are some brown bananas, there are some yellow bananas. There's a lot of different kinds, and we can recognize all of them. So this is just something that's innate. This is something that we do as human beings. So when machine learning started to become popular, we had to kind of look at how machine learning could be created in similar ways, in which we teach it by giving it lots of information. We have to give the tool lots of information so it can learn. So for those of you that did this activity, or you can try it later, especially if you've never seen Hindi or Chinese letters, this activity may be a little bit more difficult. Now, it's not so difficult you can't figure it out. It's not incomprehensible, but there are some ways to kind of look for discrepancies. So when you get to the end of this activity, there's actually two characters that don't fit anywhere. Which is kind of a fun little prank to play on you all. But yeah, so when you get to the end of that activity, you get Hindi letters, Chinese letters, And then these other letters, the Korean letters, they don't fit in anywhere. So you're left wondering, what happens there. And this happens in machine learning too. Sometimes, a machine learning tool will get a data set, it will get some information, and it won't know what to do with it because it's so dissimilar to anything it's been taught how to do. So if we teach it to recognize Chinese letters, we teach it to recognize Hindi letters, and we give it some other letters from a different language, it won't have any clue what to do with those. So when your brain starts to look at these different characters, you start to do the same thing that AI does. You start to look at the arrangement. You look at the shapes, the patterns, the styles, the symmetry, the vertical lines, the horizontal lines. Just like the Abraham Lincoln system would start to look at the shape of the eyes, the shape of the face, the exterior facial features. So our brain does the exact same thing. So in order for artificial intelligence to get really good at doing something, it has to be shown something a lot of times. Now, the difficult thing with image recognition is that, when we show an image, there's often background information. So how does the AI know which of the things it needs to identify from that image? For example, in this image, there's a dog, a bicycle, a tree, a car, the road, a porch, all kinds of things. So in order for the AI to be really good at recognizing these things, we have to teach it a classification. So in artificial intelligence, we call each item a class because no one item is exactly the same. So if an AI sees an image of that dog, it may never see that particular dog again, but it might see another dog like it, or it might see that dog in a different pose, or it might see that dog with its mouth open and its tail up. So it has to start to create a class, and that class is called dog. And then here are the millions of different kinds of dogs there are. Same thing with bicycles. There's a class called bicycle, but we got red bicycles, blue bicycles, bicycles with 2 wheels, bicycles with small wheels, etc. So the AI has to start to understand that there are lots of different kinds of the same kind of thing inside that class. So, here's an image of a bunch of dogs. So here are all the dogs. All these dogs are different. They have different facial expressions, different colors, even though some of them are similar. Like we've got these black and white dogs that are very similar, but there are differences in their nuance and in their shape, and even the camera angle. The ears are up, the ears are down, got the tongue out here. So AI looks at all of these images and it says, okay, these are all dog. And it starts to remember that these are all dogs. So next time it sees dog, then it can help us it can predict at a higher rate that this is dog. So the way, the question I would ask the students now is, so how can AI be trained to learn something? Well, the only way for it to learn, and I've said this multiple times, is for you to teach it. So we have to give it lots and lots and lots of information. So if we want to build an AI system that is really good at predicting what a picture of a cat is, then we have to provide it with literally millions of pictures of cats. Because think about cats, there's so many different colors and shapes in the hair, and different, they all look similar. We can identify them as cat, but to an AI, they're all very different. So we have to show them lots and lots of examples so that it can start to understand, oh, this is cat. Even this one is cat. Has no hair, but that's still cat. So I like to compare this to kind of think about, when you first learned how to read. Think back to your childhood. Maybe you're in first grade, second grade, you're learning how to read. Now, the teacher doesn't just hand you a 400-page novel and say, here you go, start reading. No, you have to start off small. You have to first understand and interpret individual letters. Then with the letters, you can make out words, and you start off with small words like the boy and the dog, the girl and the cat. Then you start to add paragraphs to that. And so you're building fluency, and you're building understanding, you're building repetition, and you're learning. This is how we learn. So AI is very similar. We have to teach it slowly. We have to show it some examples, then we have to test it. Then we have to show it some more examples, then we test it. So in order for you to better understand how that works, I have another activity for you. So this is activity 5. And we're going to actually teach a machine learning tool how to identify something. And so the machine learning tool that we're going to use now, you have to think about it as it's an infant. It's a newborn infant, and it doesn't know anything at all. It's never been taught anything. So we have to teach it something first. So the artificial intelligence machine learning tool that I showed you earlier in the webinar, where it used the webcam, that one already knew a lot of stuff. It already knew what dogs and cats and bicycles and backpacks and mugs are. But this machine learning tool knows nothing. So I'm going to stop sharing my Google screen here, and I'm going to show you what this tool looks like. All right, so in the link that was shared earlier, this is activity number 5. This is called the image upload classifier. So it's called that because we're only going to upload image files. We're not going to use the webcam for this. So this tool is able to recognize the difference between 2 different things. So I've also shared with you a link to a Google Drive folder of images. So I've got a folder of bananas and I got a folder of apples. So what you can do is you can download these images to your computer, and then you can upload them to this tool. So what I've already done that. So I've already added 9 examples of bananas, and I've already added 9 examples of apples. So the way it works is you just click on upload an image, and then if I wanted to add, I'm going to add the 10th banana. So you can see now I've got 10 bananas in there, and then I'll add a final apple, apple 10. There we go. So now I've got 10 apples and 10 bananas, and they're all different pictures. So you can start teaching something with as little as 10 images. If you want it to be really, really good, like I said earlier, you need like millions, but we can kind of get somewhere with 10 images. So now I'm going to click on training. So it's going to, this is where all of that hidden layer stuff happens. So it happens really quickly because the AI has become really good at doing that. So now I can test it. So I'm going to upload an image, not one of these 10 images, but a different image of an apple or banana. So I've got these other images that are labeled, A test, B test, etc. Let's do B test 1, which is a banana, and there it loads the image. And now I'm going to click on predict. And it predicted successfully that this is class 1, 100%. All right, so if I was to upload, pretty much any picture of an apple or banana, it would be able to tell me that it's an apple or banana with a good confidence rate. But if we want to test the constraints of this and the parameters of it, let's throw up the red banana. So that I've got an image here called the AB Joker. And I call these Joker images because, for students, it's fun to kind of trick the machine learning tool. It's fun for them to build something and then try to break it. So let's predict. Let's see what it does. So it says it thinks it's a apple with a 66% confidence level. That's a pretty high confidence level for it not actually being an apple. So this is a tool that you can use, and you don't have to use pictures of apples and bananas. You can put pictures of your dog and your cat, or student A, student B. You can do facial image recognition, pretty much any kind of image. But you need at least 10 images for class 1, 10 images of class 2 for it to work. If you want it to work better, you need more images. Then you start testing it to see how well it works. If it's not working well, then there may be some issues with your testing data, which I'll explain more detail about why that might happen. But this tool is free for you to use, and it's very user-friendly. There's no coding involved, but it can only identify 2 things. So think about it as like a baby machine learning tool, and it doesn't know anything until you teach it some things, and it can only learn 2 things at a time. So it is really cool to use and interesting. But I want to make sure I get through the rest of this presentation. I still got a few more things to uncover and unpack. So please hang in there with me. All right, so now I want to talk to you about the main topic for today is about bias. So if this tool starts to work and we show it the red banana and it says it's an apple, well, that's incorrect. So the reason why it is incorrect is because there must have been some kind of bias in my data. And we tend to think about bias as a negative thing because bias is talked about negatively in the media and social spheres. But bias is just a thing that happens. So where was the bias in my data? Well, there's 3 main types of bias when it comes to data. So the 3 main types of data bias, the first one is that there's not enough data. So, I only gave it 10 pictures of apples and 10 of bananas. That's not really enough for it to be really good at identifying. So the first type of bias is that there just isn't enough data for us to quantify. The second type of data bias is that the data isn't diverse enough. So if I just show it, 4 pictures or 10 pictures of the same red apple, it will be really good at recognizing that one apple. But what happens when I show it the brown apple or the yellow apple? It won't know. So we need the data to be diverse so that it's a representation of the full spectrum of that class. So if the class is called banana, we need to show it every stage of banana, every color of banana that exists. If the class is dog, then we need to show it all the breeds of dog and all the different types of dog. So it's important that the data is diverse. It needs to contain different angles of images, different types, and a complete representation of that class. Okay, and this is a huge one. This is where most machine learning tools get stuck, is by not having enough diversity in their data. So it's like the Chihuahua images in the muffins. There wasn't enough diversity in those images for the machine learning tool to tell the difference between the muffin and the Chihuahua. The next type of data bias is if the data is not clear. So we need high quality images. We need clear images. And it's also really good if the images are free of background information. So, if I take a picture of an apple and in the background there's a red truck, the machine learning tool could start to pick up on that red truck. Because there's those hidden layers where the machine learning tool is comparing and contrasting the pixel values of the images. Sometimes it kind of picks up on the wrong shade of red, and it starts to think like, oh, we're trying to learn what a red truck is. So we need to make sure that the data is clear and it's a good representation of that class. So it can identify clearly what you want it intended to recognize. But really, so the machine learning tool, the one we just looked at, the apples and bananas, it's only as good as we are able to teach it, and it's only as good as the training data that we can provide it. So if we only give it a limited number of images and there's all kinds of bias in our data, then the machine learning tool is going to predict incorrectly. So we have to kind of work really hard at making sure that our data is as free from bias as possible by providing it with lots of data that is diverse, and data that is clear. Those are the 3 main data bias problems that exist in machine learning. But as humans, there are also hundreds of different kinds of bias, and just to kind of start to connect the ideas of human bias and data bias, these are just a few examples of common types of human bias. There's gender bias, which means you prefer one gender over the other, or ageism, where you have you think differently about certain people of a different age. And then the horn of the halo effect is like, this person is a good person, this person is a bad person, etc. But really all people are just people, and sometimes they do good and bad things. Some people are old, some people are young, some people are different genders. Those are all different biases that we start to get from our culture and our upbringing, or even influenced from media and television. And so those biases affect what we think about what we've learned. And so the similar things can happen in machine learning with the different types of data bias. So I want to show you an activity really quickly about how does bias creep up into our brains. So our human brains, not the machine learning brains, but in our human brains. So I'm going to ask you to look at 3 images. And what I want you to do is I want you to pretend that your brain is a machine learning tool. And the machine learning tool, the only thing it can do is classify objects. So all you can do is if I show you an image, all you can say is the name of that image. For example, if I was to show you an image of my coffee mug, you would just say coffee mug instead of person drinking or a person holding mug, just coffee mug. All right, so here's the first image. So what can you classify from this image? Now your brain may start putting other labels on this image, but if you're a machine learning tool, all that you see is hand, knife, food, board. All right, those are the most clear things that we can make out from this. All right, and if my machine learning tool is really good, I might even be able to recognize that this is a vegetable instead of a fruit or something else. So maybe hand, knife, vegetable, board. All right, so as a machine learning tool, that's all I can do is classify those objects. Here's the next picture. All right, so a similar kind of image. So I see, as a machine learning tool, I would see hand, I would see knife, I would see wood. I might say bowl, or whatever. I'm not sure what this is, so I may not say anything about it, but I can identify the hand, the knife, and the wood. Right, so there's my classification. Here's the next image. So in this image, I see, as a machine learning tool, I see hand, I see knife, I see pants, I see cabin light, maybe, I don't know. So how did you guys feel, when I started showing you these images, though? So it's really impossible for your brain to not go beyond the classification. You can kind of like, yeah, you can say, oh, I see hand, I see food, but really your brain is concocting a story. Your brain is adding bias to it because of your previous experience. Maybe you've chopped food before, or maybe you've known someone that chops food before, so you can identify this experience. And you know already that this is a food preparation for a meal. There's a grilled zucchini here. They're making a salad or something. Okay, in this image, your brain starts to make a story based on the biases that you have from your own experiences. This looks like we're starting a fire. We're getting some kindling going. There, maybe there's something going on at a camp. This looks like it's burned. So maybe we're getting something ready for a fire. And this is the one that really gets people, is like, you just can't stop your brain from going, oh my God, horror movie, scary, So, it's impossible for our brains to differentiate and deviate our biases from what we see in front of us because of our experiences, because of our culture, etc. So, this is what happens with bias. Bias adds data, adds information that may not be there, in actuality. So, in this image, really, in actuality, all that's there is hand, knife, and vegetables. But our brain adds our bias by adding a different label. It adds cooking, chopping, dicing, etc. Same for this one. Chopping, carving, whittling, making fire. And then this one, it immediately evokes a reaction, of scary, horror movie, fear, etc. Even though if we were to just purely, classify the object that we see only, hands, knife, pants, what's scary about that? It's nothing. It's just a classification. But our bias, our human bias, is added on top of that. So sometimes our brains add more information that isn't necessarily there. Now, that's not a bad thing. It's actually a bonus for us as human beings, because we look at this image and we get an emotion, we get a feeling, we get a reaction. And those reactions that we have help us to stay safe. They help us to interact in the world. So when I say that humans have bias, it's not a bad thing. It actually can be a beneficial thing, but it's important to understand what that bias is, because the bias gives us a lot of information. It gives us conditions, it gives us context and cues that we can use to make meaning from an image that an AI can't do. So an AI can just label things, but an AI wouldn't necessarily be able to tell you if a situation is harmful, or it wouldn't be able to extrapolate the feeling of that image. So it's cool that humans can do that. We can use our bias in a way to help us understand and make meaning from the context of what we see around us. But if we want to be better understanding of those biases, it's always good to reflect on those biases and see where they're coming from, and to see if they have any errors. Kind of like the machine learning, sometimes there's data errors because of bias. So it's possible for humans to do that too. So as a kind of a capstone project for this particular topic, something as a thought experiment, what I would ask students to do is I would tell them that you have a job, and what I want you to do is design a machine learning tool that can identify lizards. And so what would you do to prepare and to teach this program how to do that? And so as a thought experiment, you could ask the students to brainstorm and think about what they would need to do so that the machine learning tool was very accurate and was free of bias. So how can we start to collect data of lizards that's free of the 3 different types of data bias, which is not enough information, diversity, and clarity, okay? So, then if the students really wanted to, they could go ahead and, find a bunch of pictures of lizards and then try this out and see if it works. And they could use the tool that I showed earlier. And also, I'm going to share with you a bonus tool that allows you to use the webcam. So the tool I showed you earlier, you have to upload each individual image one at a time. But on the link, there is an additional bonus tool that you can use that's called the webcam classifier. And the webcam classifier works really cool because all you do is open up the webcam and then you hit click. You click on the take a picture button and it takes a picture. You click and take another picture. So that one's really cool for facial recognition because you can take like 10 pictures of your face with 10 clicks. You can just go click, 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 and there you got your first 10 images. Then someone else comes in, they click 10 times, and now you've got an facial image recognition system. Or, some of my colleagues have even tried with cats and dogs and stuff, so you can do whatever with the webcam. But the projects that we're sharing today are all part of the Computer Science Education Week Hour of Code. So if you want to try these projects and learn how they work with code, you can use this link here. And it's also in the document I shared earlier, but my colleague Beth will put the link here to our free coding projects. So today in the webinar, we didn't touch any coding because I felt that would be just a little bit too much, because I really want people to understand the nature of bias and how that affects machine learning. But if you want to build the webcam classifier with HTML, CSS, and JavaScript, you can do so by following the link to our free projects. And by the way, these projects are also freely available on the Hour of Code website. So if you were to visit the Hour of Code website and see the list of projects that they have available for Computer Science Education Week, you could filter those by who makes them. And so if you just search for BSD Education, you'll find them all there as well. But the AI webcam image classifier is our new project for Hour of Code, and we're really excited to get people to use it. The project itself is going to cover some of the same information that I've covered in this webinar with the slides, but then at the end, you're actually going to use HTML, CSS, and JavaScript to build the project. That project is a little bit more difficult, so we kind of reserve it for maybe middle schoolers. But if you've got younger students who are looking to code for the first time using HTML, CSS, and JavaScript, they can try these other projects that we have for free. One of my favorite ones is called The People Who Inspire Me, in which the students pick 3 people from their life, either real or fictional characters that inspire them. They find an image of that person, make a new website, and they describe why that person was inspiring to them. And they can then show that off to their family and their friends. If students want to build something with interactivity, they can make a trivia game maker with JavaScript in which they come up with their own trivia questions and answers. So please do take a look at the different projects we have available for free and on Hour of Code. And I want to thank you all for joining us on this extra special webinar in the webinar series that we've been hosting at BSD Education. And we're really close to the end of the hour, but I do just want to see if there were any questions, comments, concerns, or information on the topics from today. And I'm just going to go back and look through and see if there's any questions in the chat. I've got no questions. Does anybody in the room want to raise a question or a comment? If you think of something, you can always reach out to us later through social media. And also, the live recorded version of this will be on YouTube. And, you're also welcome to share out any of BSD's free projects for Hour of Code, as well as any of the content that I have shared today. Thank you all for joining us live, either on Zoom and on YouTube. And we hope to see you on our future webinars. I'm giving a shout out to my colleague Ming, who I see now. Good to see you. All right, cheers everyone. Thanks. Have a good rest of your day, and